we're talking about the big theorems with continuous functions right now. That, like, if somebody told me they took real analysis and they took it at University of Montana, I would still expect that they would know some big theorems, like they would know the Cauchy criterion, they would know Bolzano-Weierstrass, they would know the definition of continuity, they would know these theorems that are about to go up on the board, and these definitions. So we're actually hitting the meat of, and you can kind of even see why integration comes next, because these theorems and definitions that you're pulling, they're all used to prove those big theorems in integration. So that's why logically, like if you think about who wrote the books, textbooks in calculus, they were all math professors. Once you go through a math program, you're polluted for life, and you kind of think that way. So they naturally came up and said, derivatives come first, integration comes next, because all the theorems that prove the integral stuff comes from right here. That's not normally, I think, the best way for a student to learn. If you really want someone to learn who has a weak background, what you want them to do is integration at the same time as derivatives. That way they get reps in and get used to it. And I've taught calculus like that. But and it's actually very interesting watching that. But this is why our calc books are set up the way they are. Okay, so when we have a bounded function, on a set, what we mean by that is that there exists a constant m bigger than 0, such that f of x is less than or equal to m. And that's for all x belonging to A. So pictorially, what I think, one of my favorite functions in the world is arctan. And my daughter's actually taking Calc 3 right now. She told me polar moments of inertia was the worst thing that she's seen, but she told me that when she hears about the arctan, she mentally just stops. And I told her that's not going to mentally stop. Arctan is actually a good inverse trig function because, number one, it models so many things for us in applied math and in computer science, so we like that function. But also it has certain properties, and the Taylor series is nice, and you can take the derivative of the Taylor series pretty easily. The derivative of arctan is 1 over 1 plus x squared. Anything I'm rattling off the top of my head means that this, as a math person, that's something you have to know because it's in my head. Anything that's not in my head is probably something I've never used, again, other than when I took the class. Has a nice derivative, expand the Taylor series. And Taylor series for the derivative of arctan is super easy. Take the 1 plus 1 over x as the geometric series and stick in x squared. Plug it in. So nice. That's what arctan looks like. That's a bounded function. And your capital M in this case would be 1 because everything's bounded between -1 and 1.
So the absolute value.
It might be pi, minus pi, but let pi equal 1. It works. If it's pi, then I'll just normalize this as 1. I'll just multiply by a constant. But it's squished in between two things. So I think of a function pictorially as bounded means that I can actually find a limbo bar above. And what's that bar you hop over? Yeah, the limbo bar, initially you hop over it, right? No, you go under it. So you have the limbo bar on top where the function can't go above it, and you have a bar on the bottom that the function can't go below it. It has to have one on top and bottom. And that's why this guy's an absolute value. Right?
So if there's different spots, so say at the bottom it's 1 or -1, at the top it's
It doesn't say it has to be the best.
Very nice.
All right, good that you internalize it, because I'm going to ask you to come up with a definition for the other way. What if it's not bounded? See if you can make an inequality definition. And that's This is what we do when we do research mathematics in pure math. We come up with our own definitions, right? It's hard, actually. It's harder than it seems. Tell Isabel Palisek the other day. You're coming up with your own your hypothesis, so you can make it work. You're creating the theorem.